Good morning, students. Last lecture we have discussed the nurse equations. Okay. Now, now today we are discussing the calculation of the cell potential using the nurse equations. Okay. First calculation. First consider the cell. Here the cell cadmium solid in contact with the cadmium 2 plus ions aqueous uh, double vertical line, that is the salt breeze Cu2 plus aqueous ions in contact with the copper electrode Cu. Okay, so these are the cells. We have calculate the cell potential. Okay, from these cells, cell is the cadmium in contact with Ca2 plus in contact with Cu2 plus ion in contact with Cu solid. Okay, first write the cell reactions. We have calculated the cell potential, so we have to write the cell reactions. Oh, we are writing the cell reaction first. So left hand electrode is the cadmium, and at the left hand electrode oxidation takes place. That is the Cd is converted to Cd2 plus ions. Cd solid gives Cd2 plus ions plus 2 electrons. Why 2 electrons? There are lose the 2 electrons because there is a oxidation reaction takes place. Okay, now consider the cathode. Cu is the cathode, and at the cathode reductions takes place. Okay, Cu is the cathode, and at the cathode reduction takes place. So Cu2 plus ions is going to Cu. So we can write the right hand side. Cu2 plus 2 electrons gives Cu reduction half reactions. Okay, now write the overall cell reactions. Overall cell reaction or net cell reaction is the addition or sum of the algebraic sum of the two oxidations half reaction and reduction half reaction. So here first oxidation reaction, write the first oxidation reaction, then reduction reactions. Okay, 2 electrons and 2 electrons are cancelled. 2 electrons and 2 electrons are cancelled. So on left hand side we get the Cd solid plus Cu2 aqueous gives on right hand side Cu2 plus Cd2 plus aqueous and Cu solid. This is the overall cell reaction or net cell reactions. Okay, or net reactions. Okay, here number of electrons are 2. N is equal to 2 because total electrons are 2. 2 electrons are released as oxidations used to in the 2 electrons in the reduction half reaction. That is the only 2 electrons are released uh, at anode, and these are 2 electrons are used at the cathode. So N is equal to how many electrons? N is equal to 2 electrons. Okay, we have the Nernst equation. E cell is equal to standard cell potential minus 0.592 divided by N log to the base 10 concentrations of product divided by concentration of the reactant. Okay, so here in this reaction Cd is the solid and Cu is the solid, so we cannot write here. Okay, so cell potential E cell is equal to E standard cell minus 0.592. N is the 2, so write here 2 log to the base 10 and concentration of product divided by concentration of the reactant. Here the product is Cu2 plus and reactant is sorry uh, product is Cd2 plus and reactant is the Cu2 plus. We cannot consider the Cd solid and Cu solid because they have the concentration of solid is unity. Okay, they are not taken in this reaction. So only here Cu2 plus ions and Cd2 plus ions, and Cd2 plus ions is the product. So if you write here Cd2 plus ions, concentration of Cd2 plus ions, and divided by concentrations of the reactant. Which is the reactant? Cu2 plus ions is the reactant, so concentration of the reactants. Okay, do you understand? I hope you are understood. Okay.